Hello students, welcome to my channel. Today we will be learning the real numbers. So before we start with the real numbers, we will first check what is the number system is. So hope you know what is the number system is because in the junior grade we have learned about few part of the number system like natural number, whole numbers and integers. But just as a recap, I will just demonstrate you or tell you what is the natural number and all this. So first of all, the basic of a number system is natural number. Okay. So natural number is denoted by the letter n. What is called a natural number? Natural number are the numbers which can be represented, uh, which is positive and that can be counted. So only the countable numbers are 1, 2, 3, 4 and so on. We can't count the negative numbers, so negative numbers are not natural number. Even we can't count 0, so 0 is not a natural number also. So natural numbers are these numbers denoted, this set of the numbers are denoted by n. After the natural number it comes the mm, whole number denoted by this set of numbers are denoted by 0. What are the whole numbers? Whole numbers are all the natural numbers including 0. So we can first write all the natural numbers. Okay. And the only addition will be 0. So 0 is a whole number, but it is not a natural number. Okay. Next comes the integer. We have also learned about integers. Integers denoted by z, but in some book it's also denoted by I, but we will denote it by z. So integers are all the whole numbers, so we can just write all the whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on. But integers can be negative also, so the addition will be the negative of all the natural numbers. So -1, -2, -3, -4 and so on up to infinity. Minus infinity and other is minus. This side is positive infinity and this side is negative infinity. So that's about the integers. And we also know about the number line. So here today we will be learning about the rational numbers. So today we will be learning about rational numbers. So these rational numbers are denoted by Q. The symbol is Q. What is called a rational number? The definition of the rational number is the numbers which can be represented in the form p by q. So of the form p by q where p and q both are integers. This symbol is called belongs to. It means p and q both are integers and q is not equals to 0 because we know nothing can be divisible by 0. So denominator the q cannot be 0. These are called rational numbers. So this is the definition of a rational number. So according to the definition, all the integers, that means natural number, whole numbers and negative of natural numbers are also rational number. Why? Because you choose any integer, say I'm choosing 4, let me choose 4. So the 4 is the integer. It also can be represented in the form 4 by 1. Or if you choose a negative number, say -5, that also can be represented in the form p by q, where the q, the denominator, is 1 and we know 1 is an integer. So all the integers, that means all the natural number, whole numbers and negative of natural numbers, are also a rational number. So what is the addition to the rational number? Because we can see the integers, the whole numbers and the natural number doesn't include any fraction or any number which is in decimal form, like 2.3. That's neither natural number nor whole number nor integer. Such numbers can be included in rational number system. But we have to be sure that the rational numbers, we have to check that, we have to be sure that that number which we are including or checking must be represented in the form p by q. So that's a rational number. Okay. So let's see how we can represent the rational number into a number line. So let's see how we can represent a rational number into a number line. So we can write number line representation. So this is the number line representation of rational numbers. So let's see how we can represent a rational number into a number line. For say I have to represent 3 by 4 into a number line. Okay, so I can see it's an uh, proper fraction. It is less than 1. So if I represent it into a number line or in a real number line, the number should lie in between 0 and 1, because this is between 0 and 1. So first of all we will draw a line. So let's draw a line. Okay, I'm not good at drawing the straight line using this whiteboard, so pardon me if it is not a proper straight line, but I am trying my best. So this is 0, this is the positive sector, and this is the negative sector. Maybe later we have to extend the positive sector, because here we need the positive sector much more. So say this is 1, and I'm trying to get a same length, because the 1 and -1, that's the definition of a real number line, that each and everything should be equally divided. So this is 1 and this is -1. Now I can see the denominator part. Okay, the denominator part is, so this denominator part is, we can see it's 4. So between the section between 1 to 4, we should divide it in equal 4 part. 1, 2, 3, 4. We can see 1, 2, 3, 4. It has been divided into equal 4 parts. So each part represent 1 by 4. So this is 1 by 4, this is 2 by 4, this is 3 by 4, and this is actually 4 by 4, which is equals to 1. So I need the number 3 by 4. So this is the number we need. So this is the number we need. So this will be the representation in real number line. Okay. Okay, so that's easy. So you guys try to represent the number 1, 1 by 2, 3, 2 by 4, sorry, 3, 2 by 3 into real number line. Okay, you just pause the video and try that. Okay, hope you have done the number line representation. Here is your answer. This is the answer for the first question, and this is the answer for the second question. We can see this is 1 and then 1 by 2, so it's between 1.5, exactly middle of the 1 and 2, so it should be here. and this is 3 2 by 3, so it's 3 and then it the 2 by 3 part, so that means it would lie between 3 and 4, and this is the representation 3 2 by 3. Okay, now we will be solving few questions, the exam type questions which you can expect in the exam. So the first of all, we mostly have a question something like find a rational number which lie between two given number. Okay, so the question is find a rational number no, lie between, sorry, it's lying between the question is given, say 1 by 4 and 1 by 3, and the second question is given 3 by 8 and 2 by 5. Okay, so let's try to solve it. Actually it's very easy, we can solve it in so many ways. So let me give you a property of a rational number. Say we have two rational numbers, say a and b. Okay, so the average of a and b, that is uh, a plus b by 2, that will lie between a and b. So we can write that a and b should be, a plus b by 2 should be between a and b. So that is how we can find a number lie between two given number. Okay, that's the theoretical way to do it, but we have so many other ways which we can apply here. So I'm going to do the first one in this method. So the first one we can write, it's the number which between 1 by 4 and 1 by 3 can be 1 by 4 plus 1 by 3 divided by 2. So it's 7 by 24. Okay, the 7 by 24 will be in between 1 by 4 and 1 by 3. And for the second case, it's 3 by 8 and 2 by 5. So we can simply find by adding and by finding the average of these two given numbers. So 3 by 8 plus 2 by 5 divided by 2. So it will give you 80. 5 8s are 40 to the 80, and 15 plus 16. So that will give you 20 31. So 31 by 80. Okay. So this is a number which lie in between the given number. But we have so many numbers between these two. You can find any other number also, doesn't matter. So this is when we need to find a one single number in between two given number, and that's the easiest way. If you want, just need to find one single number. Okay, but we have one other type of question which says that you have to find a number which is we have to find three numbers lie between two given number. Okay, three numbers. Earlier it was one number, now it is three numbers. So the question is find three, it can be more than three also, find three rational numbers between 1 by 5 and 1 by 4. So 1 by 5 and 1 by 4. So let's see how we can solve it. I'm choosing I can do it in the previous way also, but I'm choosing a different method so that we can find any number. So it is 1 by 5 and 1 by 4, right? So first of all, we will convert it into a like fraction. Okay, what is called a like fraction? So what is called a like fraction? If we have uh, two fractions having same denominator, say if we have 7 by 18 and 19 by 18, these two will be like fraction because they have same denominator. So we can write same, it must have same denominator. Okay, so I'm first trying to convert it into like fraction, and we know how to do it just by multiplying the cross. You can just multiply the cross denominator, so it will be 4 by 20 and this will be 5 by 20. Okay, after that what you can do, you can simply multiply the 10 or 20 with the denominator and numerator both. So it will be, if I multiply with 10, it will be 40 by 200 and it will be 50 by 200. Now it's very easy, even I can find 9 numbers between 40 and 40 by 200 and 50 by 200. How? I can write the numbers are 41 by 200, 42 by 200, 43 by 200, 44 by 200, 45 by 200, 46 by 200. I know I have to write only 3, but I'm writing the complete one so it will be easy for you to understand how this is happening. 49 by 200 and okay, the last one will be 49 by 200. All these numbers will lie in between 1 by 5 and 1 by 4. So this all will lie between 1 by 5 and 1 by 4. Okay, so now pause the video and find a rational number. Find three rational number between, sorry, find three rational number between 2 by 5 and 3 by 4. You can write down the answer in the comment section also. Okay, I hope you have solved it and uploaded into the comment section. If you have done that, I will definitely answer you whether your answer is right or wrong. Okay, next we will be learning the terminating decimal. What is called terminating decimals? So first of all, we have to understand what we mean by the word terminating. It means something is going to end, or something that will be having an end. So, so terminating decimals are those decimal when we have a fraction and we can try to convert it into a decimal representation. We know sometimes we can complete the long division method and we will be having a definite answer. And in some cases we know that we cannot have a definite answer. The answer will be the division will never end. So such type of numbers where the division ends, we have a definite answer. That's called a terminating decimal. And those numbers who don't have any termination in decimal representation, that means the long division will go on for infinity, those kind of numbers are called non-terminating decimal numbers. So terminating decimal numbers, you can write down the example as 2.23, 2.23, or you can write minus 4.56, or even you can write 9.87965, and so on. But it should have a, it should not go on, it should have it after decimal. It can have 30, 40, 50, 60, 90 decimal numbers, I mean 90 places, but it must have a end. You should have a end of the decimal representation. So that's the terminating number. Now here we will be learning a very interesting stuff, that without actual division, if I give you a number and fraction, how you can predict that number is going to have a uh, it's going to be a terminating decimal or not. So let me give you a number, 5 by 32. Let's first look at the question. 5 by 32. My question is, without the long division, can you predict whether this answer is going to be a terminating decimal or a non-terminating decimal? So probably it's quite difficult. It seems quite difficult unless we know the rules. There is a rule which says that for a number a by b, that means for the numbers which can be represented in the form fraction. So for a by b, if b can be represented as 2 to the power m into 5 to the power n, that means if I prime factorize the b, I should have only the factors 2 and 5 other than 1. So if a denominator of a fraction or a rational number can be represented in the from 2 to the power m into 5 to the power n, then the rational number will be a terminating decimal. Otherwise it will not, it will be a non-terminating decimal. So that means we have to prime factorize the denominator. So we have to prime factorize the 32. So I'm going to prime factorize 32. So if I prime factorize 32, it will give you 2 to the power 5, because we all know 2 to the power 5 is 32. So it is actually in the form 2 to the power m into 5 to the power n. Now the basic question comes that where is 5 to the power n? Okay, let me provide you. This is the 5 to the power n part. Okay, so that means this 32 can be represented in the form 2 to the power m into 5 to the power n. Hence it's in terminating decimal. So if I represent 5 by 32, it should give you a terminating. It's in terminating. Okay, so it's in terminating decimal. So let's try one other number, say 11 by 24. Okay, so I'm going to do 11 by 24. So if so that means we have to prime factorize 24. So 12 twos are, so or 4 six are, so it's 3 into 2 cube, because 3 eights are also 24. So 3 into 3 into 2 cubes. So we are having an factor 3 other than 2 and 5, right? So it's a non-terminating decimal. So that means if I convert it into a decimal number, the division should not end. So it's a non-terminating decimal number, the 11 by 24. Okay, so you guys try two other number, say 27 by 80, and the fourth one 5 by 9. So you pause the video, find the answer, and then resume the video and write down the answer in the comment section. Okay, if you have any other doubt, you can even ask me that in the comment section. I always will be looking for your comments. So that's an terminating and non-terminating. This is how we can determine without long division the terminating and the non-terminating decimal. Under the long terminating decimal portion, something is there which is called recurring decimal or repeating decimal. So next we'll be learning about repeating or recurring decimal. I will be using the word repeating because that's the most commonly used word in this chapter. So what is called a repeating decimal? We all know that the recurring decimal or the repeating decimal. It's 2.33333, and we can write it as 2.3 bar, right? So it means the 3 will be repeated after the decimal. Okay. So not each and every case you can have a repeating decimal. In case of a non-terminating, there will be certain numbers for which you will be getting an repeating decimals. The most common questions we have here is to convert our repeating decimal into a fraction, because a repeating decimal also a rational number, and as it is a rational number, we can convert it into a form p by q. I'll be doing the sums for three numbers. It will be 0.3 bar, second one will be 2.23 bar, and the third one will be 0.14 bar. The bar is only above 4. Here the bar is on above 2 3. Okay, so the first one, first of all, I have a separate video on this, that how we can convert a recurring decimal into a fraction. I recommend you to look there, because there I have taught you on some simple tricks through which you can convert a repeating decimal or recurring decimal into a fraction. Okay, but here I will be, as I am right now in the syllabus, so I will be teaching you in a theoretical way. So first thing first, that you have to take the given number as x. The most easiest thing, I have to take it as x. Okay, after taking it as x, what I next need to do, I have to check after decimal if there is anything who don't have any bar. So I'm talking about something like this. This is a number which don't have any bar. But fortunately, I don't have any such number who don't have any bar, because right here after decimal every number is having bar, so it's good. It's a good sign. Next, I have to check how many digits after decimal actually having bar. So obviously, yes, the answer is 1. So there is only one digit who are having bar. So I have to multiply both side by 10. If I have two digits after decimal having bar like this one, I have to multiply it by 100, correct? So if I multiply it, okay, so I can represent it like 333333333, and if I multiply it by 10, it will give you 3.33333333, and so on, right? So let name it as equation 1, and let's name it as equation 2, and subtract equation 2 from equation 1, so it will give you 10x equals to 3.33333 dot 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 minus x equals to 0.33333 dot dot dot. Okay, so if I subtract it, I'll be getting 9x equals to 3, because after decimal the entire thing you can cancel it. So that means you can write x equals to 3 by 9, which will give you 1 by 3. So this is the fraction representation, or in a rational number representation of this recurring decimal. Okay, I think it's clear. Let's do the second one. Otherwise, you can just pause the video and repeat that section. That's the first question to the first question once again, and then I recommend you to go for the second one. So let's go for the second one. The second one is given 2.23 bar. So the second one, 2.23 bar. So that means it can be written like 2.23, 23, 23, 23, and so on. And I'm taking that as x. So that means x equals to 2.23, 23, 23, 23, and so on. So as I told you, I have to check if any number is there who don't have after decimal who don't have any bars. So there is nothing such numbers. We after decimal we have only two digit and both are having bar above it. So it's good. We have to multiply it by 100. So it will be 223.232323 2 3 dot dot dot. So that's the equation 1, that's the equation 2, and subtract equation 2 from equation 1. So that will give you 99x equals to 2 point, sorry, 223 minus 2, that will be 221. And we can just write x equals to 221 divided by 99. So that will be the fraction representation of this particular recurring decimal. Let's go for the fourth question. It was 0.14 bar, right? So let's do that. It was the third one, 0.14 bar. Now the bar is only above 4. So it can be written as 0.14444444. I'm taking it as x. So that means my x equals to 0.144444 and so on. So first of all, we have to bring the number who don't have any bar above it after decimal to, I have to transpose it to before decimal. I have to send it before the decimal. So that's why I'm going to multiply it by first by 10. So that will give you this recurring decimal. That means right now the 10x equals to a number where after decimal only the recurring part is there. That's your first objective, that after decimal you should have only the recurring part, nothing else. Now I have to check after how many digits are having bars. So I can see 1, so I have to again multiply it by 10, this one. So that's going to be equation 2, and that's going to be 14.44444, so on, the second one. And I'm going to subtract the equation 1 and equation 2. So that will give you 90x equals to 13. So x equals to 13 by 90. So this will be the representation in rational number or in fraction form. Okay. So now guys, try these questions. Say the question 4, convert into the questions are 1.3 bar, 0.34 bar, 3.143 bar. So you solve this question and I will be giving you the answer in the comment section if you post your answer. 0.34 bar. Okay. So I definitely check your answers in the comment section. So that's the representation in fraction. Okay. So we are right now completed the irrational number part according to the CBSE syllabus. Now we will be doing the irrational numbers. So what is called a irrational number? A number which neither can be expressed as a terminating decimal or nor can be represented as a repeating decimal is called a irrational number. Okay. So right now we are doing irrational number. So irrational numbers. So what is the definition I told you just? The numbers which neither can be expressed and terminating decimal or nor as a repeating decimal. So these numbers will be neither terminating nor repeating decimal. This kind of numbers are irrational numbers, usually denoted with q complement or sometimes q complement. Okay, so these are the representation of the what you call the irrational number, but it's little bit hard to find this representation because most of the cases the books don't provide you the irrational number representation because actually don't have any proper representation, but in some books you will find this because it logically true. Now let me give you one example of irrational number. Say it's very easy, 0.01001 0.001 and so on. So it don't have any repetition. You can't find a pattern which is getting repeated again and again and again. So it's an repeated. This is an example of a irrational number. Or else you can put under root any non-perfect square like 3, like 5, like 11, but don't put any negative number under root. So it's 7, say 39. These are irrational numbers also. Okay. Now, what are the properties of irrational numbers? Okay, just a second. Just cube roots of non-perfect cube numbers also can be represented as a uh, irrational number. Cube root of 7, cube root of 10. All these are example of irrational numbers. Okay, so let's see what is the properties of a irrational number. Okay, that's important. So first one is sum of two irrational need not to be an irrational. So irrational plus irrational need not to be an irrational, can be rational or irrational both. Difference of two irrational need not to be an irrational. So irrational number minus irrational number can be rational or irrational both. Third, the product of two irrational need not to be an irrational. So irrational multiplied by irrational can be rational or a irrational both. The fourth one, quotient of two irrational need not to be an irrational. So irrational divided by irrational need not to be an irrational. It can be rational or irrational both. But sum of a rational and a irrational always will be an irrational. Rational minus irrational or irrational minus rational. So always will be an irrational. Okay, that also can be written as irrational plus a rational. Irrational minus irrational. Product of two rational and irrational is always irrational. So rational into irrational is always irrational. And quotient of irrational and a rational and irrational is always going to be an irrational. So rational divided by irrational is irrational, or irrational divided by irrational also give you the same thing. So these are the properties of irrational numbers. Okay. So now we have the number line representation of a irrational number. That's quite important, that how to represent a irrational number into a number line. Okay, so let's see how we can represent, say, root 5 into a number line. So the question is, okay, so represent root 5 in a number line. So first of all, we will draw a number line. I don't have the compass and such things right now, so I will try to uh, use my tab to do it. So it might not be so much perfect. Okay, so that's 1 unit, that's 2 unit, that's 3 unit, that's 4 unit, that's 5 unit. I'm trying my best to represent it. So first of all, this root 5. Okay, so if I have to represent root n, I have to take n minus 1 into consideration. Okay, so that means if I am going to represent 5, I have to consider root 4. Okay, so that means I have to go 4 under root 4 is equals to 2 actually, right? So I have to first take 2 unit and then 1 unit. So using your compass, first cut a length 2 unit from here. First cut a length 2 unit here. So that will be your first cutting 2 unit. And then draw 1 unit here. So draw 1 unit. Then you have to do what? You have to join this to point. Okay. Now what happens? This will be an perpendicular. So what happens? This is 1 unit and this is 2 unit, right? So let's find the length of the perpendicular. It will be under root 2 square plus 1 square, which will be under root 5, right? We got 5. Now how to represent that root 5 unit? This is the length root 5. Now I have to represent it into the number line. So what I'm going to do, I will put my compass over here, over the point O, okay? And then take the measurement up to this point, up to here, and then I will just draw an arc. So say the arc is intersecting here. So this will be an representation of root 5. So where the arc is intersecting, that will be the representation of root 5. Okay. Probably in the next video, I will use an compass and all this to do it properly. But I hope you have understood the concept. I hope so. But if you have any doubt, you can ask me so that in the next video, I can just show you the procedure properly. Okay. Now, next part of our chapter is real numbers. We have done irrational and the rational number, but in the starting we have told that we are going to start with the real number chapter, and right now we are doing real numbers. Why? Because the real number, the 90% of the real number set is the combination of the rational and the irrational numbers. That's why we have first learned the rational number, then we have learned the irrational number, and then I am going to solve the real numbers. So what is the definition of a real number? You will find so many definitions of real number, but please try to remember this one, because in the grade 11 this definition will help you. A number whose square is non-negative is called a real number. A number whose square is non-negative. So that's the important definition, that a number whose square is non-negative is called real numbers. So every real number is either rational or irrational. So you can just say rational plus the irrational numbers. The combination is real number. Okay. So rational and the irrational, if you add them, you are going to get a real number set. Under real number, we have few questions, and mostly those are related to rationalization. So we will be talking about that. For say under root AB, that's the first thing we are learning right now. Under root AB, you can write it as under root A into under root B. Second one is, say you have under root A by B, you can write it as under root A divided by under root B. The third one is, if you multiply under root A with under root A, it will be A. Okay. So next we'll be learning what the most important property of the real numbers, that is rationalization. Rationalization. What is called rationalization? Look, I can give you so many examples of a real number, which is a combination of a rational number and a irrational number. Say 2 by root 3. It's a combination of a rational number and a irrational number. The rational number is 2 and the irrational number is 3. But you can't have a number like this. The denominator cannot have a irrational number. So what we need to do, we need to convert it, we have to rationalize the denominator. Now to rationalize the denominator, what you need to do, you need to multiply with the rationalizing factor. In short, that's called RF. So that's called rationalizing factor. So that's called RF. What is rationalizing factor? For root 3, the rationalizing factor is root 3. What is called rationalizing factor? If we have a rational number, the rationalizing factor will be something to which if you multiply the given rational number, you should get a irrational numbers. Sorry, if we have an irrational number, rationalizing factor will be a number with which if you multiply the given irrational number, you must get a rational number. Look, we are getting 3 here. So for root 3, the rationalizing factor is root 3 itself. But for 2 plus root 3, the rationalizing factor will be, the RF will be 2 minus root 3. So how to find the rationalizing factor? It's very simple. You just need to change the sign before the irrational number. So you have to change the sign before the irrational number to solve it. So we will be multiplying the numerator denominator both with the given rationalizing factor. So we will multiply it by root 3, the numerator denominator both. So the denominator will become 3, the numerator will become 2 root 3. Okay. So now what happens? Look, this number is acceptable because here the denominator is not a irrational number, it's a rational number. So that's called the rationalization. Okay. So let's try the second question. Say we have uh, 1 by 2 plus root 3. So the rationalizing factor is 2 minus root 3. 2 minus root 3. So you have to multiply the numerator and denominator both by the rationalizing factor. So if I multiply, I will be getting in the numerator 2 minus root 3. 2 minus, sorry, 2 minus root 3 by 2 minus root 3 into 2 plus root 3. So I can write 2 minus root 3 by 4 minus 3, or 2 square minus root 3 square, and that's equals to 2 minus root 3 by 4 minus 3, and that's equals to 2 minus root 3 by 1, and that's equals to 2 minus root 3. So what formula I have applied here in the denominator? I have applied a plus b into a minus b. A minus b is equal to a square minus b square. So applying the formula. Okay. So what next? Next, let me give you a few such questions which you have to solve and upload the answers in the comment section. It's very much important that after learning one concept, you should practice the questions. You can even practice the questions from R.S. Agarwal or R.D. Sharma or NCRT or whatever you have. So, and if you have any other doubt related to this chapter or this concept with any particular question or particular concept, you can ask me in the comment section. I will always happy to reply you. So in this case, you have to rationalize the given questions. One other is root 3 minus 1 by root 3 plus 1. What you need to do? Rationalize the given. In the type 2 questions, there will be two variable a, b or xy or mn or pq, whatever it is. You have to find the value of such variables. So let's see one question. So the question can be root 3 plus 1 by root 3 minus 1. That's equals to a plus b root 3. You have to find the value of a and b. Remember, a and b both are real numbers. So we have to rationalize the left hand side. So we will be multiplying the numerator by the rationalizing factor, which is root 3 minus 1. Sorry, root 3 plus 1. So in the numerator and denominator, we are multiplying root 3 plus 1. In the numerator, we can see we can apply root 3 plus 1, the whole square formula, which will be a square plus b square plus 2ab. So 3 plus 1 plus 2 root 3 by 3 minus 1, which is 2. Then 4 minus 4 plus 2 root 3. So we can write it as 2 into 2 minus 2 plus root 3 by 2. 2 to get cancelled. So a plus b root 3. Now we have to do what? We have to compare the left hand side and the right hand side, that is the rational part with the rational part, irrational part with the irrational part. So you can write a equals to 2 by comparing the real part with this side real part. So we are getting a equals to 2 and root 3 equals to b root 3. So obviously the b is going to be 1, hence the value of the variables are a equals to 2, b equals to 1. So let me give you a few such questions which you have to solve and upload into the, or write down the answer into the comment section. Okay, pause the video and solve these questions. The questions are 5 plus 2 root 3 by 5 minus 2 root 3 equals to a plus a minus b root 3. So you have to find the value of a and b. Second question is 5 minus root 6 by 5 plus root 6 equals to a minus b root 6, and you have to find what? You have to find the value of a and b. Okay. Now some definite questions from this exercise. Sometimes we have such questions, and these questions are very common in exam. The questions given is, if x equals to 4 minus 15 under root 15, then find the value of x square plus 1 by x square. Find the value of x square plus 1 by x square. So what we need to do, first of all, we can see we have to find the value of 1 by x. So 1 by x equals to, in order to solve it, we have to find the value of 1 by x. Because if we apply the formula, we need x plus 1 by x. So 1 by x equals to 1 by 4 minus root 15, and we have to do what? We have to rationalize it. So we have to multiply it by rationalizing factor, which is 4 plus root 15, and in the denominator also 4 plus root 15. So 4 plus root 15 divided by 16 minus 15, which will give you 4 plus root 15. Now what? Now we have to solve the we have to find the x plus 1 by x. Okay, because in the formula we know we need this value. So 4 minus root 15 within the bracket plus 4 plus root 15 within the bracket. So it will be 4 plus 4 8, because root 15 will get cancelled. Now I can directly apply the formula. X square plus 1 by x square equals to x plus 1 by x the whole square minus 2 into x into 1 by x, get cancelled. So x plus 1 by x is 8 square minus 2, which will be 64 minus 2 62. The formula that I have applied here is a square plus b square. Let me write it down. A square plus b square is equals to a plus b whole square minus 2ab minus 2ab, and a minus b whole square minus 2ab. Okay, now next part. So in the next part I will be giving you few hot questions which you have to solve, because it's again very much important that you should be able to answer the hot type of questions also. So let me write down the hot type of questions in the below, so you can answer them into the comment section. Okay, so here are your hot questions. Okay, I think the concept of this chapter is little bit clear now. If you have any doubt, any question, you can always ask me. So these are the HOTS questions. HOTS stands for, I think you know, higher order thinking skills. So the questions are 2 plus root 3. Find the value of, find the value of x square plus 1 by x square, and like the other one just did, and x cube plus 1 by x cube. Okay, x cube plus 1 by x cube. And the other one is 3 minus root 8, 1 by 3 minus root 8 minus root 8 minus root 7 plus root under root 1 by under root 7 minus root 6 minus 1 by under root 6 minus under root 5 plus 1 by under root 5 minus under root 4 or only 2 is equals to 5. You have to show that. So that. So what next? You have to write down the answers of these hot questions into the comment section below. If you have any other doubt, you can always ask me. I also provide the personal one-to-one session for CBSE, ICSE, IB, IGCSE. If you need any personal session, you can always contact me. So you can write down your comments that you want to take the session from me into the comment section below. In the next, I will be uploading the series of videos of the all the grades, all the chapters solved, and I also try to put the videos over RS Agarwal exercises. So hope you have enjoyed the video. If you have any suggestion or any particular doubt or any particular doubt related to the concept, you can always ask me about it. Okay, thank you, and don't forget to comment, share, subscribe, like the video. So thank you very much.